my person. We have Rob, Danya, and Joseph. You're my holdouts. Come on. I know you still want to go. All right. Okay. So, questions that you guys have from the homework sheet?
Yes.
I'm asking.
Yeah, I know.
Okay. Yeah, take it out. Yeah, feel free. Now, I'm guessing since on Monday, it felt to me like we cleared up a whole lot of your questions, that 12, 13, and 14 aren't going to cause you too much trouble, unless you weren't here and you didn't see it. I know, I agree. Totally screws my week up.
Yeah. Not that I minded it. What's your
No,
son
that's,
also?
I didn't like the switch back and forthness though. That was not cool.
Wait, what happened? They said
Closed and then it wasn't.
Really? I
Oh,
was asleep.
oh, well, yeah. First it said closed, and then it said, oh, that's a mistake, 2 hours delayed for the next hour plus. And then it went closed.
Good thing we were all.
It was very annoying because I
Ridiculous.
it was just slept-ish, but no, I had to wake up every time they changed it.
I know. It's craziness. I was like, can we not just make up our minds? Do you know what I mean?
Did your son have hospital?
He gets off school for a sneeze of snow.
Is he off today?
Oh, he had a delay today, but no, he wasn't off today. Which is a shock.
Really?
It is a shock. Because if there's white on the ground, they go down, not fast. Here's the little ramp. They shut down like that. Okay, so I'm looking for day 4 homework. So do you guys have any questions on day, whatever that is? The day 2 homework sheet? Any of those problems from in the middle? In other words, 12, 13, 14, do you feel like you're okay with those? Yes.
Can you just go to the answers?
I don't, hold on a second. This is number 3 in this class. I've gotten to the 3rd binder yet. I think we haven't. Sorry, you didn't hear me growl. Okay, hold on. Yes, I'm just digging for them because I know I haven't finished. And it's easier to dig them up like this rather than redo them at the drop of a hat off the top of my head. Let's see if I can find one. I already had the answers done for you. Nope, that's practice test 6, which is coming your way soon to a theater near you. Just kidding. Yeah. Oh no, you know what? I wouldn't have done these because I didn't assign them in a previous class, so I can tell you the answers and/or write them on the board. Might need a calculator, might not. Okay, so 12. 12 has 4 answers, right? A, B, C, and D. No idea why that parentheses is so far off to the right, but that's okay. 0 to 7 would be 13. Part B is from 5 to 0, so that just flips the sign. Because from 0 to 5 is 10, it's negative 10. I'm just going to put the answers after you guys. That's all I asked you for. And then 3 times the area of that would be 30. So that's what I get for number 12. 13 also has an A, and B, and C, and D. 0 to 6 is 3. 6 to 3, 6 to 3 would be 1. 3 to 3 would be 0. Love those. And negative 5 times that effect from 3 to 6 would be positive 5. 14. That's probably Sue. And sorry, I'm talking to myself. 6 is 10, and that's 2, so that's 8. And B is G of X minus F of X, so that's negative 2 minus that, so we get negative 12. And C is 2 times G of X, so it's negative 4. And 2 to 6 is 3 times F of X, so it's 30. Sorry, I probably don't need to do this out loud.
Yeah,
I do 12, 13, 14, duh. I was like, wait, I circled 15, duh. I have to do that one. So those are your answers for 12, 13, and 14. So we're clear. Yes?
Y for 12 feet, it's from 5 to 0, and then maybe from 0 to 5.
When
So
they give you,
Y is a negative.
if they, if they flip flop them, it's a property of integrals.
Okay.
Just change the sign, that's all it does.
It's like when you take it from right to
When you
left.
go backwards, exactly, same idea. Yep. So these aren't, you saw me just put these answers up. They're not truly things that you need to actually calculate, other than like sometimes you're adding areas in your head. But they're little problems that you have sorry guys, we're in sigmas, or we're in areas, intervals. You have calculus integral rules for. And again, the nice part about this was, and you can probably now agree with me, the nice part about these on numbers 11 through 15 is that you weren't given a function. You really didn't have to mess with what's the area under, you didn't have to compute it. They just gave you some givens and you worked with it. I mean, in some respects, when you guys first had it that Friday over the weekend, you're like, I don't know what to do because I don't know what the function looks like. But in reality, I think they're actually easier in a way, sort of. Do you kind of agree with me a teeny bit? Now that you've sort of seen the whole light and all that good stuff. You're good there? Okay, so put your names on both homeworks. They might be on the same sheet of paper, which is fine, and then pass them in for me, please. You could have done them on the same sheet of paper, you could have done them on the back, could have done them on the front. It's totally fine, you could have done them on a separate sheet. I usually get here around 6:50-ish. Okay, sure. Thank you very much, sir. You're gonna turn in your permission slip, we want you to go, right? Yay.
Dig out the other sheet.
All right, you dig out the other sheet, Kimberly, thank you. He's back there digging.
Laying straight.
It'll take 5 hours. Look at you with your little red line there. Very cool, awesome.
I got 3 sheets.
Nope, this is it, because I just, yeah, this is fine, this is good.
I was looking for my class directions on my soda, and I was like, you should have seen my desk. I had,
Yeah,
like, all of
lots
the
of
worksheets
math.
out.
How
And
fabulous is that?
my mom texted me, was like, you've got a lot of paper saying that's like, you need these for school. I was like, no, I think I have everything, but I don't think I have everything.
Oh, no, not that, not that, not that. Okay, all right, let's see if I can figure out where we are here and what we're doing as of the moment. Okay. Let me give you a little area investigation. Here's where we're headed, guys. I'm gonna try to just proceed at a pace that is not rapid speedy, but go through this and see if I can get you to a point where I can give you some work to try. Our goal is this, to go from what you've been doing and understanding about areas into being able to do it with calculus, okay? So this little sheet right here is designed, I do, right up here.
I got 3 sheets.
There it is, 3.
Wow.
I didn't think I could carry 3. Jeez, beans. All right. Our goal is, like I just said, being able to go from the calculus, or from what you're being asked, into the calculus. Now, instead of me using the overhead and scrolling and scrolling and scrolling, I probably don't need to. And please look at what it says. So on your papers, it says graph number 1. Please do that for me. Just wing it. It doesn't have to be a perfectly straight line. You guys obviously know number 1 is a straight line, right? So y equals 3. What's it look like, guys?
Horizontal line.
Horizontal line. Beautiful. And it goes through y equals 3. Okay. Now, it says graph these 3 functions between the x variables of 0 and 6. So that's because I made your x-axis go from 0 to 6. You with me there? Okay. So just do number 1 for me. So number 1, you've got your picture, and it basically looks like this. You guys can see that that's purple, and this goes from 0 to 6. Now, what I want you to do is not to fill out the other 2 graphs just yet. Please jump down to number 4, okay? We're going to fill out that little table right there. Now, the table means this. What I want you to do on the table is think x is how far you've gone over, and the area is the area under the curve from 0 to that point. Because it says, you're gonna find, in the first quadrant, you're gonna find the area between the graph and the x-axis from t equals 0 to t equals x. Now I'm just using another variable, t, because x is gonna be some unknown number, do you know what I mean? Like where we start and stop finding the area of. So 1, 2, 3, 4, 5, and 6. So the first one means, if you were to find this area between 0 and 1, so this area right here, what kind of shape is that, ladies and gentlemen? It's a rectangle. How big is that rectangle? How, no, yeah, but this is a rectangle. How big is the area there? 3. Do you all agree with that?
Yes.
Okay, next rectangle. This time, they don't want you to stop at 1, they want you to consider going over from 0 to 2. Is that also a rectangle? No, a square, a rectangle. And how big is that area? So each time you do this, your area starts along the y-axis and goes over to the endpoint. So do you guys agree you get 6 for your area?
Yes.
Okay, now, if we ask what happens when we go over to 3, even though my picture doesn't look like it, what is that shape? Go ahead, say a square. All right, so the answer there would be 9. Are we good? Yes. Okay, then if we want to go over to 4 and include all that, the answer would be beautiful. And then 5, awesome. Beautiful, beautiful, beautiful. Okay, so when you take a look at this, here's what I want you to observe. Notice at the bottom, it says observations. And the bottom says observations, but quite likely, we could actually put the observation next to this. In fact, look at the numbers. For the area for 1, from 0 to 1, you get 3. From 0 to 2, you get 6. And then you get 9, and I bet you guys could predict 7 if you didn't even need to draw. You got the pattern here. So would you guys agree with this? Just right out to the side. We're just doing the observation over to the side. How do you predict the area? Depending on what x you stop at, do you agree with that? Josh just said the area is 3x. If you went over to 7, you guys said it would be 21. If you went over to 12, it would be 36. Now, here's what I want you guys to think about. The original function was 3, okay? And we just figured out the area function is 3x. And I want you to think in terms of calculus for a minute. Ready? If I said to you, do something in calculus to this that you already know how to do, and this is the answer, what operation did you just do? Derivative. So what you're doing today, right now, is going from the derivative to the original function. That's called doing an antiderivative. That's where we're headed. I just want you to see that. There's a little connection there. It's not really, like, unlikely. It's very likely that's how this is all built. Okay, so now we're taking a look at number 2. And you guys are drawing a picture. I hate when this thing gets knocked over. And it goes from 0 to 6. And notice that your scale is a lot taller. Good golly, my eyesight is horrid. Does that go up to 15 on your papers?
Yes.
Okay. I don't think it needs to, because I think probably 12 would quite be sufficient, because our function here is y equals 2t, or if you want to think of it as y equals 2x, but it's just a straight line. What's the slope, by the way? 2. And what's the y-intercept?
0.
0, right, okay. So again, we're going to do x, and we're going to fill out the table, because I think doing these together, like one followed by the other, so we're jumping down to number 5. Okay, 5 is the area, the accumulated or cumulative area from 0 to wherever you stop. So if we do from 0 to 1, we're not going to be finding where rectangles or squares, are we? So how do we find the areas? What shape do you guys have here? Triangles. So our area formula is going to be 1/2 base times height. Now let's think about this for a second. If our little function here said y equals 2t, if we take in 1, then that means the height of our triangle. Remember, my scale is not perfect, okay? So the base of this width obviously is 1, and the height is 2. So what's the area for 1? 1/2 base times height. So do you guys agree we get 1? That little triangle would have an area of 1. Okay, if we go over to 2, so this time we're going to go over to 2. Now, if we do that, what's the height of this shape? Because now what we're doing is finding the area still of a triangle. It still goes back to the origin, or the y-axis. It's 1/2 base times height. What's the height here, guys? That would be 4, wouldn't it? And now what's the base? 2 units long. So 1/2 times 2 times 4 would give you 4. Nice job. So let's look at 3. If we did 3, first of all, the height of 3 would be 6. Would you agree with that? So again, 1/2 base times height. So 3 times 6 divided by 2. 9. Okay. After 3 terms, usually your brain can kind of make a guess. Now, just with 2 terms, you're like, not so sure. We might be adding 3, we might be doing something else, right? We're going to multiply by 4 if I'm trying to find a pattern, right? But I don't think we're adding 3 each time because then this would have been 7. And I don't think I'm multiplying by 4 each time because then this would have been 8. Do you agree with me? So I think there's a different kind of pattern, but look at the number and then this. Look at 1 and think, how do you get 1 from 1? Not really sure. How do you get 2 from 4, or how do you get 4 from 2? Say it again. You square it. How do you get 3 to turn into 9? You square it. Now let's not bet on it. Let's just go ahead and keep on going. If we found the next area, it would be over 4 and up 8. So 4 times 8 is 32 divided by 2 is 16. Does that satisfy what we thought would happen? So can we go ahead and just wing the other 2, 25 and 36? You guys are okay with that? You've seen the pattern? That's what I wanted you to do. Find the pattern here as we go through. So the area formula is take x and do what with it to find the area between 0 and that x? X squared. Nice job. So the area formula is x squared. Now, here's what I want you to think about, guys. The original function was 2x. Again, look at the relationship. X squared, if that were your original function, is its derivative 2x. So there's going to be a way today for us to go from an original function's derivative to the original function. There has to be a rule for that. That's what we're going to be learning. That's called an antiderivative. Should make sense to you. It's the opposite of a derivative. Okay? So we've got the first picture and the second picture. Now, the third picture. Please look at the function for a minute here. Look at your function. It's given as y equals 2t plus 3. Now, do you remember last week when we were drawing pictures? And when we drew, not just pictures like the SpongeBob and stuff like that, when we were drawing area pictures. One of the things that you can do is this. You can think of this as y equals 2t and y equals 3. Both of them separately and just add their areas. Do you follow what I'm saying? Now I can graphically draw this. If we draw this, what's the y-intercept of this line? 3. So the y-intercept is here. I don't know that I needed to draw that out, but I'll just kind of do that sort of dotted line. And then from there, what's the slope? Up 2 and over 1. So what I want you guys to see is that essentially it's this rectangle, so it's number 1, added with number 2's areas. Do you see what I'm saying? Every single time. So what I want you to realize is that we can do this in pieces. We've already done this. We've already done the rectangles areas. Area 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we've already done the triangles. So we don't have to recreate the wheel and keep trying to find areas of trapezoids. I mean, why bother doing that? We've already got the rectangular areas and the triangle areas on these 2 tables. So what I'm going to do actually for number 3 is put the table that's down on number 6. This is really number 6. I'm going to put the table down here. X and area. And let's just fill this out without even drawing it. I don't even think you need to draw it. Do you all see what I mean by you don't need to draw it? You just need to add the areas. So this table said area from 0 to 1 was 3. And this one said the area from 0 to 1 was 1. 1, 2, 3, 4, 5, 6. So the area for this would be 4. How are we doing, guys? So I'm just simply adding this area with this area because that would be the rectangle with the triangle and add it together. Do we get that? Okay, let's do the next one. 6 over here, added with 4 is 10. Beautiful. 9 added with 9. I know you guys can do that in your heads. 18. Cool. 12 added with 16. Is that 30?
28.
28. I'm an idiot.
26.
28. Yeah. If you take 12 and add 16, you get 28. Let's try that again. Okay, if you take 15 and add 25, you end up with 40. And lastly, if you take 18 and add 36, right, 18 times 18 is 36.
This is 54.
54, I was going to say, 18 times 3 is 54. And I'm trying to put 4 and start writing a 3. Now, this may not be quite as easy to do. If we want to try to find an area function for this, wow, we cannot write that. It's not going to be as easy to recognize, but think of what we just did. We took this area function, 3x, because this was the area of the rectangles, plus we did the area of the triangles right here. Does that make sense to you? That's how we found it. That's how we found the area formula here. So it's you got to take the 3x, you got to add it with the x squared. So again, I want you to think of this. If this is your function, what's its derivative? 2x plus 3. And isn't that what number 3 is? So we found the area function for this was, it was just equal to x squared plus 3x. And again, if you think about the original function and put it in terms of x, that's the relationship that I want you to see. So you're like, huh, all right, your interest is piqued at this point, quite certain. Yes, definitely. Okay. Now, flip your papers over to the back side for me, please. Now it asks you, because we've got the tables and I'm leaving them on the board, left them on the board on purpose, to sketch the graph of the area function, okay? So when we get to Roman numeral 3, the first graph right there, we're doing the area function for y equals 3. So I'm going to do this in orange. So I want you to look at the area function for y equals 3. Now, we could do this point by point. We could go 1 is 3, 2 is 6, and 3 is 9, and all the way down the line. So we could go 1 is 3, and then 2 is 6, and 3 is 9, and keep on going. Now, technically, it didn't connect to 0, but what kind of a shape did I just draw? What shape did you just draw? Okay, and don't we already have the equation of that line said right here? This is saying plot your area function. We already know the equation for the area function is just 3x. Isn't that the line that starts at the y-intercept of the origin and keeps on going up 3 and over 1? Isn't this just the line? How do I want to write this? The area function was 3 times x. And that's what we just sketched. So we're now sketching this stuff into the box. Follow me there? Like I'm literally making a graph out of these. And so I'm really just sketching what we concluded, the observation. Give a little bit of sense to you. Okay, so we can look at it either way. We can either do it point by point, or we can do it using our formula here. I'm going to stop. I'm not trying to speed through this. Stop and ask me questions. You feel like you're okay with this so far? Point plotting 101, but I'm hoping that you're making connections a little bit between them. Okay, so the next part of part 3 says graph the area function for y equals 2t. So what we're doing is we're using these numbers. 1, 1, 2, 4, 3, 9, 4, 16, 5, 25. What is that, guys? It's a parabola. Isn't that y equals x squared? Yeah, absolutely. So 1, 1 would be here, and then 2, 4 here, and then 3, 9 would be here, and obviously it's going to go for the origin, but it's just the right side. I mean, granted, it didn't have the 0 part, you know that. I'm just sort of connecting because I want you to go, okay. Remember, we already found this. The area was x squared, because here's what we came up with. Ta-da! Our area was x squared. So we're just plotting x squared. Now the third and final one is the sum of the other two, right? It's the other two added together. So we could again plot it point by point, or be smart about it. Here's what I mean by be smart about it. This left, wow, can't spell today. The area function for the last one, underneath y equals 2t plus 3. What did we get for our formula? What was our area formula over there? I didn't box it in orange, but I could. It's x squared plus 3x, right? X squared plus 3x. So what kind of shape is that? X squared. If x squared is its biggest exponent, it's a parabola, right? It's a parabola. It's going to go up on both sides, right? Okay. Okay, so if we had to solve this and set it equal to 0 to find what the zeros are, you guys would set it equal to 0 and factor an x out. Now, we don't really have to do it this way because we can just do this point plotting 101, but I want you guys to see your x-intercepts will be 0 and -3. Now, this may not involve negative numbers. Remember, we're counting areas. We don't have negative areas. This said first quadrant only, right? So let's put our points on here. So the first point should be at 1, 4, and then 2, 10, 3, 18. These are going to get really big. all the way down to 654. So I'm gonna go down here and get 654. The 54 is there, 27 would be about half of that, just to give myself some idea of what's going on here. So there's 1, 2, this is 3, 4, and 5. And I just want to plot these literally. So the first point was 1, 4. That's going to be like way down here on this one y-axis. And then 2, 10 is going to be not quite half of that. And then 3, 18, a little closer to 27. These are starting to look like a straight line because my graph is off of it as far as the y-axis goes. And 4 is supposed to be 40. Is that right? So 40 is probably a jump up to about here. Sorry, 4 is 28. I can't read my own writing, can I? Nope, can't. And then 4 is 28, which would be slightly above. That's 4. 5 was supposed to be at 40, right?
Yes.
Okay, and then 6 was 54. So I'm not sure if you guys are getting the curvature of it because I made my graph, the y-axis so big, but it should be perfect. Now, if we went through and did this and found the actual graph for the parabola, what you guys would find is that it does this. It has x-intercepts at 0 and at 3. But we didn't go that far, remember, we just kind of did, we just stopped it at 1. So we found the area starting at 1. So that's the plan. Okay, so hopefully you're like, okay. All right, so here's our deal. Part 4. This is where we're getting extremely close to our big picture. Part 4. 4, y equals 3, the area function was what? And then that's going to be called f of x. So we're just putting it all together. And for y equals 2t, area function was what from what we've already done? We're going to call that g of x. And for y equals 2t plus 3, our area function was what? And we're going to call that h of x. And then we're going to do in part 5, 5 is a v, and then we'll speak. F prime of x is equal to, sorry, g prime, I'll just put what you guys have on your papers. And h prime of x is equal to. Okay, what did we find for our formula for a of x? Wasn't it 3x? Is that right? I'm looking at the far left side of the board, hopefully I boxed that in orange. And the area for the second one was x squared. And this one was those two added together. So if you haven't gotten the big drift, here's the big drift. In purple. If we want to take the derivative of this, and we can either do it down here in the limit of 5, or we can do it right up here. And we call this f of x. What's the derivative of 3x? 3. And what's the derivative of x squared? 2x. And then what's the derivative of both of these? Don't you just do them in separate pieces? Remember when you did the derivatives in separate pieces? That's why we do areas in separate pieces. So this is just going to be 2x plus 3, right? Okay. So that's it for observations. What you need to realize is that when you're finding the area, how do I want to say this? When you're finding the area's formula is the, you tell me what's the derivative of what? Like look at f of x. Area formula was 3x. The original function would have been, or the derivative would be 3. So weren't we finding the area? Here's what we're going to notice. Look, if we want the area under 3, look at that. We want the area under 3, that's what this said. And the answer to the area formula was 3x. Let me draw a little connection. So if I want the area under 3, to get the formula, I just have to think, if 3 is the derivative, what's the original function? And that's the area formula that we calculate the area formula. If I have 2t as the thing that I'm sketching, and I want to know what its area formula is, it's x squared. Or you guys can consider this 2x if you want. So think, x squared is the derivative, or x squared is the original function, 2x would be its derivative. So here's the idea. If you were given something like this, try to find the area underneath 2x. This is the area from 0 to 6 of 2x. Notice you've seen stuff like that before, however, we've not done this with calculus yet. This is the thing that you're going to sketch, and you're going to be drawing and finding the area under this. No, yes. Yeah, sketch this area, and the area would be equal to x squared. Like, for example, if we wanted to go from 0 to 6, we'd be able to find the area from 0 to 6 by using this formula. If we wanted to go from 0 to 3, we could use this. Do you know what I'm saying? Okay, so that's,
Can you like let me really simple instead of that version?
yes, that's getting way ahead of yourself. You could try to find the infinite area, but it would
Well,
be really,
not like actually find it.
yes,
I guess.
but it would be really difficult to, because if we tried to find the infinite area, it would be like, hugely crazy. Okay, so worksheet, fundamental theorem of calculus. Did I copy that? Yeah, I think I did. Did I give you guys this? Yes. Oh, I'm sorry, I'm talking to myself. Just ignore me for a minute here. I'm trying to find something that goes along with this that would be like, this is day 2, investigation. This sheet only had a front and back, right? Yeah, okay, got it, okay. Is there a homework that goes with this? I just need to pull out the black binder and be able to tell you. This is area, under the curve, day 2, definite interval. Ow. Day 4, function found by community area, function calculus. Okay. Day 4, day 4, got it, okay. I know what I need to hand you. Okay. Now, let me, go back to, how do we do that? Like, once we get, I'll write down what I'm talking about. See how there's a 0 and a 6 on that last one over there? Okay, so I'm sorry I have to switch boards, but say we were trying to do this, and the last little I wrote in purple. I wrote 2x right here, and then dx right here, and then this is 0 to 6. And so if we figured out the area formula was x squared, here's what we do. Does that look like a straight line to you? Close to a straight line? Can't do this all in one day. It's 11:19. I'm gonna give it a shot. Let me do this for you. And I have to do the next worksheet with you guys. Rats. I can't do this yet. And there's no way I'm gonna get through this next sheet without being able to do this. Alright, just pause on that thought, keep stopping. Because there's one little bit, I don't want to try to start in 10 minutes or 9 minutes and shove down your throats. So just hang on to that thought, I'm going over with it. Keep the sheet here. Got to add on to it tomorrow. Tomorrow you're going to get a fundamental theorem of calculus. I'm not being sarcastic. That's what it's called.
Is that like all?
So obviously it's big. Why do you say that? The fundamental theorem of calculus. Well, okay, fundamental being one word. It's not like fun. Yeah. So we'll save day 4 for day 4, which is tomorrow. Day 2, this is your homework stuff.